Okay, section 2.1 talks to us about acute angles of right triangles or with right triangles. We have already looked at our trig functions in terms of angles and standard position and talking about them in regard to x, y, and r. We want to move to a more general sense away from the plane and just into a regular right triangle. And so we're going to connect the two and move to those new definitions. Hopefully they're going to make sense to you. I have an old drawing where you have an angle in standard position that goes through the point x, y, and it forms, of course, side y and side x's lengths as well as the radius, and we know how to get that. Notice also that this drawing forms for us a right triangle. And we see that box denoted in there. Now, just for terminology's sake, remember that the side across from the right angle is always known as the hypotenuse. We're going to be referring to that, so you'll want to make a note of that. Now, previously, we talked about the fact that sine of angle A, this is angle A here, would be y over r. We want to note now that in the terms of this triangle here, that would be the same as the side opposite of angle A over the hypotenuse. Similarly, cosine of angle A we formerly talked about as x over r, but now we would look at it as the side adjacent to or beside angle A over that r, which is now the hypotenuse. And the last more familiar term would be the tangent of A, which would be y over x in former terminology. And now we would see that as the side opposite of angle A over the side adjacent to angle A. Now, a lot of people have ways of keeping up with this. Sine, cosine, and tangent is typically the order you talk about trig functions in. And so they'll come out and they'll just say, well, this is O over H, thinking opposite O, hypotenuse H. This is A over H, that being adjacent and hypotenuse. And this is O over A. And to keep this in their memory, they'll talk about a little sentence. They'll say, well, Oscar has a heap of apples. Now there are a million little phrases that go along with that, but that just keeps your O, H, A, H, O, A going for your little mnemonic there. Now, I haven't written them, but know that cosecant of A is just the reciprocal of sine, so it would be hypotenuse over opposite. Secant of A is the reciprocal of cosine, so it's hypotenuse over adjacent. And cotangent of A is the reciprocal of tangent, so it's adjacent over opposite. Those you should know as well. These 6 are redefinitions for a general right triangle, okay? These apply for a right triangle. Okay. The other definitions we had with x, y, and r was particularly when we're sitting in a plane and going through a particular point x, y. Now what we want to do on the next page is apply these definitions to just a general triangle. We have a triangle over here, ABC, with sides 7, 24, and hypotenuse 25. And we're going to go through and we're going to find those 6 trig functions. So the sine of angle A, here's angle A, would be the opposite of that, opposite over hypotenuse. Well, the opposite of angle A is 7. And the hypotenuse in this case is always the number across from the right angle, so it's 25. So sine of angle A is 7 over 25. Cosine of angle A is going to be adjacent over the hypotenuse. If I'm looking at angle A again, the side adjacent is 24, and the hypotenuse is 25. And then lastly, we have tangent of angle A, which is the opposite over the adjacent. opposite of angle A is 7 and the adjacent is 24. Now ideally you can flip those around very quickly to find the other 6 trig functions. Cosecant of A is going to be 25 over 7 because it's the reciprocal of sine. Secant of A is going to be 25 over 24 because it's the reciprocal of cosine. And cotangent of A is going to be 24 over 7. That's a 7 because it is the reciprocal of tangent. Now for comparison purposes, I want to go ahead and do the ones with angle B also. So now we're going to think about angle B rather than angle A. Sine of angle B is opposite of B, which is 24, over the hypotenuse. Cosine of angle B is the adjacent to angle B, 7, over the hypotenuse. Tangent of angle B is the opposite of B, which is 24, over the adjacent, which is 7. And we can very quickly find the other. Cosecant of B is 25 over 24. I'm just flipping over sine. Secant of angle B is going to be 25 over 7. And cotangent of B is going to be 7 over 24. Just finding those inverse trig functions, or reciprocal trig functions, my bad, on that language. Alright, now here's what I want you to notice. Sine of A, right here, is the exact same value as cosine of B. Likewise, tangent of A is the same as cotangent of B. And secant of A is the same as cosecant of B. Of course, we realize that there are other ones that match as well, but the reason that you're seeing this similarity is because these functions are known as cofunctions. So two things I want to highlight about cofunctions. First of all, A and B are complementary. That means angle A and angle B have to add up to 90 degrees. Now guys, a triangle has 180 degrees. If the right angle is 90 degrees, you're forcing A and B to have to sum to 90. So they're complementary. That's given. And then we have again the cofunctions that when we look at those complementary angles, the cofunction of those will give equivalent values. We're going to take a closer look at that on the next page and talk about cofunctions a little more. Cofunction identities hold for any acute angle A. That is, the sine of A is equal to the cosine of 90 minus A. So if I had the sine of 30 degrees, then that would be the same as cosine of 60 degrees because 90 minus 30 would give me 60. Notice that the 30 and the 60 are complementary and we have cofunctions. Now this is just saying the same thing, just in reverse. Also we have tangent is cofunction with cotangent and secant is cofunction with cosecant. When you look at this, you do just have to memorize the one in each group, because the second one in the list is just the inverse of it. It's the same. You can get there. Now think about this, guys. Sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. It's in their name. The biggest thing that people do is they mix up reciprocal with cofunction. I'm going to make a big note up here. Reciprocal is not cofunction. They are very different and they don't match up the same. The reciprocal of sine is cosecant, but the cofunction of sine is cosine. So be very careful with that. Now we're going to put this idea of cofunction into play and calculate some of these actual values. If I wanted to write cosine of 52 degrees in terms of its cofunction, well, cosine's cofunction is sine, and and I would want to take that 90 and subtract off the 52 to get my new correct angle. So this would be sine of 38 degrees. Notice my 52 and my 38 add up to the 90, and the cofunction for cosine is sine. I'm just using this definition right here in red. Tangent. If I want the cofunction of tangent, well, cotangent is the cofunction, and I would take my 90 degrees and subtract off my 71 degrees. So that cotangent of 19 degrees would be my cofunction. And lastly, we have secant and cosecant. If secant is my function, then cosecant is its cofunction. I'm going to subtract the 24 degrees off of the 90, and I will have cosecant of 66 degrees being my new cofunction for secant of 24. Now let's look at this last problem and see if you're really connecting. Cosine of theta plus 4 degrees is equal to sine of 3 theta plus 2 degrees. And what I want to know is, what is theta? Well, it goes right back to that page we talked about a minute ago. With cofunctions, this angle here and this angle here are complementary. That means that theta plus the 4 degrees and the 3 theta plus the 2 degrees have to add to 90 degrees, which gives me a total of 4 theta plus 6 degrees equal to the 90 degrees, which means my 4 theta is going to be 84 degrees, which means if I'm looking for theta, theta is going to be 21 degrees. And that was just based on the definition for cofunctions. I know that those angles, A and B, are complementary. We're using that same concept up here. 52 and 38 are complementary. 71 and 19 are complementary. 24 and 66, you can say it for me in your head, are complementary. And I hope that that's gotten the basic idea of your new trig definitions in terms of triangles, as well as capturing the idea of cofunctions as we go.